In this video we have the integral of a rational expression. We have a fourth degree polynomial in the numerator, and if we square this out we'll get a fourth degree polynomial in the denominator. We could divide those out and see if we can do a partial fraction decomposition. I always like to look for a U-substitution. A lot of times we let U equal what's in the denominator. In this case we could take this expression here in the parentheses x squared plus 1, take the derivative of that, that gives me 2x. That won't do me any good. What if I square this though? X squared plus 1 squared would give me x to the fourth. I'm squaring a binomial, so that would be double this product, so this would be a 2 x squared, and then this squared, the 1 squared will give me a plus 1. Take the derivative of this, that won't do me any good as far as the U-substitution there. But notice, I got an x to the fourth here, a plus 2x squared here, and a 1 here. So I'm going to rewrite this into two integrals. So one integral will be x to the fourth. I'll take the 2x squared. I got x to the fourth plus 2x squared plus 1 here. So I'll take the plus 1, and then I'll leave it over x to the fourth plus 2x squared plus 1. So this will be one integral, and this will be another second integral. Second integral will be plus, and I'm going to take the x along with this one. So this will be x. Now I'm going to leave the denominator the way it was. You'll see why in a minute here. I'm going to leave this as x over x squared plus 1. 1 to the squared. Remember that was the same thing as x to the fourth plus 2x squared plus 1. That's going to equal 2. And notice, the first integral, I got x to the fourth plus 2x squared plus 1 over x to the fourth plus 2x squared plus 1. Those divide out. So all I get is 1. So that's the integral of 1 with respect to x. So the answer, or the value of the first integral, is just x. And that's going to be plus. And then for the second one here, I'm going to let u equal to x squared plus 1. So du would be, the derivative of x squared plus 1 is 2x. And then this would be a dx. Let's divide through by 2 here. Put the 2 over here. And that just gives me x dx. So now we're going to transform the second integral into one involving the variable u. And got the dx here. So for the second integral, the x dx here, look at this right here, x dx is du over 2. So I'll put the 1/2 out in front here, and this will be du over, and then x squared plus 1, that's your u here, so this will be u squared, and then this is equal to x plus 1/2 times the integral. I'm going to take this up to the numerator. This could change the sign of the exponent. So I'm going to have that. Then I proceed to integrate then the second integral there. First one's already done. So we add a 1 to negative 2, we get negative 1, divide the coefficient by that, that'll be a minus 1/2 here. Get u to negative 1. And then I pretty much completed the integration, so I add my constant of integration here. So now I can write then x minus, and then u to negative 1. Remember, u is, for this one, x squared plus 1. The negative 1 will take that to the denominator, so this will be a minus 1/2 here. And I can write this as 1 over u, but u is x squared plus 1. So there we have it then. X minus 1/2. I can write it this way, or I can just put parentheses in the denominator and multiply by the 2. Here we have it then. X minus 1/2 multiplies the 1 over x squared plus 1 plus the constant of integration. Thanks for watching. We'll see you next time.